Assalamu alaikum. In today's lesson, we're going to talk about function. Okay? So what does function mean? So you can think of it like a machine. We have our machine. You have input, and then you get output. Okay? So let me show you an example. If x equals x plus 2. Okay? This is called the function. This is called a function. So we know x is a variable. What about if x? You can, if x, you can say y, you can call it y. It's just a variable. You can call it y, f, z, c, as you can. Okay, as you want to call it, whatever you want to call it, it's up to you. So y equals x plus 2. So we have two variables here, y and x. So x is an independent variable, and y is dependent variable. So y depends on x. When you put a value for x, you can get a value for y. So let me show you an example. When you put x equals 2, then y equals x plus 2, then y equals, we're gonna replace x with 2. 2 plus 2 equals 4. So 2 here is constant. We can't change it. Okay? So when we put x equals 1, then y equals x plus 2 equals, replace x with 1, 1 plus 2 equals 3. So we have two pairs here. When we put x equals 2, we get y equals 4. When we put x equals 1, we get y equals 3. Okay? So this is called an ordered pair, and order here is significant. You can say 1 and 3 equals 3 and 1. Okay, this is wrong. They are not the same. You have to care about it. Okay, so this is the main definition for function, and I explained it. But we have, this is not the only type of functions. We have different types of functions. Okay, for example, we have if x equals x squared, and this is called quadratic functions. If x equals 3, okay, you can say if x equals 4, if x equal a digit, okay, and this is called constant function. So the function base has no variables. So here, if x equals x plus 2, this is called the function base. We have x here, this is a variable, okay, but here we have no variables, so this is called a constant function. For that, x plus 2, this is called linear function. If x equals absolute value of x, this is called absolute value function. And we have if x equals 1 above x, okay, this is called rational function. So we have x here and the denominator, so this is called rational functions. Okay, we have a lot of different types of functions, but this video is very short, and this demo video we're not going to talk about the whole types of function. This is just an example to see what does function mean, and how to find pairs in function, how to substitute and replace x with different values, and then we get values for y. Okay, but in today's video we're gonna talk about the linear function, how to find the domain of linear function, how to find the range of it, how to graphically represent this function. Okay, let me erase it first. Let me clean this. I'm sorry, I have a problem with my screen resolution. It can't record the whole screen and the whole length of the screen. Okay. So linear function. Okay. Before discussing before talking about the linear function, we have something called polynomial functions. Okay. So polynomial functions are divided to different types. We have if x equals 5. This is a constant function. Okay, this is constant functions. Okay, don't care about my my writing here. Okay, if x equals x plus 1. This is linear function, also known as first degree function. Okay, first degree function. Okay, we have also fx equals x squared. This is called quadratic function or second degree function. And we have fx equals x cubic function. This is called a cubic function. And this is also a polynomial function. So you know polynomial functions, function have different types of function, base. Okay, this constant, linear function, quadratic function, cubic functions. Okay, but in today's lesson we're going to talk about linear function. But I mentioned these types of function to say polynomial functions has real numbers as domain. So the domain of the polynomial functions is R, unless your teacher gives you a specific interval of functions. You can say the domain here is from 1 to 5. Okay, this is specific interval of domain of real numbers. I'm sorry. Okay, but in general, the domain of any polynomial function is real numbers. Okay, so this is the domain of it. And then we're going to represent the function graphically and see how to find the range from the graph. I think to find the range from the graph is simpler and easier than finding it from the function itself, or to find it algebraically. I think it's simpler to find it from the graph. Okay, so if we have here fx equals x plus 2, and then to represent this function graphically, we have to find at least 2 pairs, but I will find 3 pairs here. So 3 pairs means we have 3 values for x, and then we get 3 values for y. So let's put x equals 0, x equals 1, x equals 2. Okay, we have our domain R, so we have to take values from our domain. So x equals 0, then y equals 0 plus 2 equals 2. Y equals 1 plus 2 equals 3. Y equals x plus 2 equals 2 plus 2 equals 4. Okay, so our 3 pairs are 0 and 2. Okay, this is the first. Second, 1 and 3. Okay, 2 and 4. We have 3 pairs here to present this function. Okay, to present this function, let me erase this, and then start to represent this function. Okay, that's good. Here are our axis. I'm sorry for that. This x dash and x, or you can say negative x, positive x, y, positive y. Okay, and this negative y. Okay, we have this, the origin point, 0 and 0. Okay, 0 and 0. Okay, this 1, 2, 3, 4. Okay, and here minus 1, minus 2, minus 3, and for y minus 1, minus 2, minus 3. Okay, here 1, 2, 3, 4. That's really fantastic. Okay, we have 0 for x and 2 for y. Okay, 0 for x here, this is the 0 of y and x. 0 and 2, 0 and 2. Here is the point. Okay, let me change the color. Okay, that's good. 0 and 2. This is the first point. 1 for x. Here is 1. And 3. And 3. You're gonna go up. 3. Okay, that's good. 3. 2. 2 on x. Where's 2? Here is 2. And 4. 4. Okay, until you reach 4. Okay, and then you attach these 3 points using your ruler, okay, not by your hand, okay, not by your hand, by ruler, okay. So this is the linear function. This is our linear function, x plus 2. So this is called linear function because you have a straight line, linear function. Okay, now we want to find our range. How to find the range? So we can look at the y-axis. Okay, when you determine the range, you have to find the y-axis. Focus on the y-axis. And you know, this line is extended. You can extend it from here and here. And you know, this line extended forever, and this line extended for infinity. Okay? So to determine the range, we have to look at the y-axis and see the whole values attained or covered by the straight line. Okay? So when we find the values, you can see this line covers the whole x-axis. Okay, the whole x-axis. Let me draw it here. Okay, here is our line, and this is y. So this line covers the whole y-axis. You know, this is extended forever, and this extended here. Okay, and this extended the whole y-axis. So our range here is real numbers. So the domain here are, and range here are real numbers and real numbers. Okay, so now we discussed 3 points here. We determined the domain, we determined the range, we represented the function graphically. I think it's very easy, and thanks for watching.